So basically in nuclear physics, there are two chapters.
Wait, so what about waves?
We will start wave after this section, right? Because wave is a lengthy section, right? So this chapter is short
Yeah.
and side by side because the old students in the group already completed first section and the second section, right? So those who are just joining this one, so they started from this section. So this chapter is short one. So they have
All
some
right.
content to practice. And after that, we will start the wave, right?
All right, sir.
So basically in nuclear physics, there are two chapters, right? The first one is related to the basic properties like the structure of atom, the proton, neutron, the nucleus. So all these types of things are included in the first chapter, right? And after that, in the second chapter, the nuclear processes like nuclear fission, fusion, radioactivity. So that is the main thing. The first chapter is the basic because that only includes the general idea about the nuclear physics and the atom. And the most of the topic you already studied in the chemistry also, because if we start
Yeah.
from the first topic, so the very first topic from nuclear physics section is related to structure of an atom. So if we talk about the structure of an atom, so you know that in atom consists of proton, electron,
Protons, neutrons,
and
electrons.
electron, right? So we have protons, we have electrons, and neutrons. So these are the elements which is included in your atom, right? So this makes your structure of atom. Okay. And we know that only proton and neutron, these two elements, so these two elements will included in your nucleus, right?
Yeah.
And electron is just revolving around the nucleus. So only proton and neutrons are making up the nucleus of an atom. Otherwise, the electron only orbits around the nucleus. So this is the concept, basic concept, we all know that. And further, if we want to write any element, just like in your periodic table, you observe different elements, you write atomic mass, atomic number of that element. So basically, you usually write the element like this in periodic table, just like in the picture. So basically, this is the element of helium, right? You all know about helium and hydrogen because these are the basic elements that we used in periodic table. So the first number that is written in subscript, so that number is actually the atomic number, right? So this two gives you the concept of atomic number, and the number which is written in the superscript, so that number is known as the mass number, right? Or we can say that this is known as atomic mass, and this mass number is made up of from proton plus neutron. So basically this number shows you there are total four number of protons and neutrons in this. Okay. Any confusion?
I'm just noting that down.
Okay. So this is the basic idea about the structure of atom. Very basic idea, right? There is nothing very much special in this. And if you talk about the atomic number, so basically the atomic number tells the number of protons in an atom, right? So basically, if you consider the same example of the helium, so how many protons are there in helium?
Two protons.
Two protons, right? So
Yeah.
because at this moment we are discussing all the things, so that is easy for us to understand. But in exam and in MCQ, sometimes you got confused that which number shows you the atomic number, which number shows you the atomic mass, or what actually represents the atomic number. So basically, atomic number represents you the number of protons in an atom. Okay. And further, if we discuss about the atomic mass, so basically, now if you want to calculate the number of neutrons, because neutrons are also a part of the nucleus.
So atomic mass minus the atomic number, so we get the neutrons.
Yes. Because from the diagram, you can easily identify, and this is a very basic concept, that if you need to find out the the number of neutrons, so we can easily find out by mass number minus atomic number. It means total mass minus atomic number. So that will give you the number of neutrons in the nucleus, right? And one more important thing, I hope you all know about that. If we consider any neutral element, so basically in a neutral atom, the number of protons are equal to number of electrons. Because sometimes they just ask you to complete the diagram or the concept like this. So always remember that if somewhere in diagram the number of protons are given, so you have to draw the same number of electrons in that diagram, right? Because in neutral body, the number of protons and the number of electrons remains the same. Okay. And one more thing that you already know about is that protons are positively charged and electrons are negatively charged. So this is the further more basic property related to the protons and neutrons are the neutral one. By name, you can easily identify that neutrons are neutral. So that's why they are in the nucleus. Okay. So this is the concept. Any confusion?
No, sir.
Okay. So this is very basic idea about the structure of an atom. And further, if we discuss about the next part that is related to the discovery of a nucleus. So let's suppose if we first consider an experiment, because this experiment is already given in your book, and in lower secondary classes you also observe this experiment. So let's suppose if we just check out the visual idea of this gold foil experiment. Can you name the scientist who performed this experiment? What was the name of the scientist who
Good question,
performed
sir. Good
this?
question.
Yes, because
Let me check.
that is very common and very basic. You
I forgot
already
about this experiment. That's why
Rutherford's gold foil experiment. Ernest,
it says here
uh,
Marsden and Geiger.
actually that was written in that, so that's why you are
It's the face of the picture itself.
okay. So
LiveScience.com.
basically, the scientist who actually gave this idea was known as the Rutherford. Okay,
Really?
okay, I will show you the experiment. Okay, so basically, this is the whole setup of the experiment. You can see the initial box which is on the left hand side on the table, that is known as alpha particle emitter, right? So basically we will further study in this chapter that what are the alpha particles, what are beta particles. So basically alpha particles, in simple words we can say these are like helium elements, right? The size and the mass of the alpha particle, the nature of the alpha particles are same as the helium atom, right? So basically this is alpha particle emitter. It means the size and the nature of the element is just like the helium, right? So basically you can also consider that helium is coming out from that alpha particle. Okay, so the gold foil experiment was series of early 20th century that gave physicists the new first view of the structure of Nobel Prize. Okay, yes, we will further discuss
Yeah.
about because Rutherford by himself mentioned in his lecture during the university. So we will also discuss that statement. What was that statement about this discovery? Because nowadays we are living in a very modern and a very scientific era. So these type of things are like very easy and very simple, very basic one, right? Because we never try to discover the things like this, right? But just a thought for that scientist to just first time try by himself or herself something new, and finally he discovers something new, right? That is completely new for the world. So you just imagine the feeling of that person, that what he was actually feeling at that time when he observed all this thing. So if we discuss about the procedure that followed by the Rutherford, so he just take the alpha particles and that is coming out from this box. Basically, alpha particles are like a radioactive material simply that emits out radiation. Just like you can take the example of the sun, okay? Because from the sun we are also getting radiations. So radiation is coming out from the box, which is known as alpha particle. And basically we are using two slides between this gold foil, before that gold foil, because when alpha particle passes through a very thin sheet like a paper, very thin paper, so basically it can be easily stopped from that, right? So we are using very strong beam of alpha particle, right? Because alpha particle consists of some mass and some energy. So when it passes through a very thin paper, so that can be easily stopped by it, right? So that's why you can see first he uses a very strong beam, then it just shorten into a very sharp beam, and then it strikes to the gold foil, which is in the circular part. And when it strikes the gold foil, because gold foil is also a very like a thin material, so you can see the deflection of that alpha particle in different directions, right? And the most important thing in this whole experiment is that you can see from the center, he just this video actually shows you the center point, because at the center point the light or that beams starts to reflect back, just like bounce back when you throw a ball to the wall, so it will just reflect back. So same type of experiment is going on during this whole experiment, right? And some of the light just reflect back, you can see, with certain angle in backward direction, and most of the light just passes on the other side. You can see multiple rays are passing to the other side of the gold foil. And from the center, um, some of the light rays are just reflecting back, or some of the alpha particle rays are reflecting back from the center. Okay. So this is the whole procedure that he used to perform in the experiment. And then he discovered that the central part of any material consists of a very heavy mass. You can see this is the particle picture of that gold foil. So when alpha particles are just moving from the surrounding, so these yellow particles are known as electrons.
The protons or electrons?
These are electrons, right?
Ah, okay. Oh yeah, my bad. Yeah,
Yes,
yeah, my bad.
because we discuss about the structure of atoms. So these yellow particles are simply electrons. Those are revolving around the nucleus. And this orange one is the
Yeah, I
nucleus,
forgot
which,
that the orange part
yes,
was the nucleus.
yes. So it consists of proton and neutron, and this is known as nucleus. So when alpha particles strike this central part, so it just deflects into different angle. Plus the central part, just you can see it completely bounce back in the same direction, right? You can just identify the direction, these arrows. So alpha particle starts to move in forward direction and it bounce back in the opposite direction from the point where it comes from, right? So this is the whole observation that is taken during the Rutherford experiment. And further, if we discuss about the diagram, so this diagram also shows you the same idea, that there is a source of alpha particle and there is a circular fluorescence screen, because alpha particles are not like the visible, just like the light rays. So what happens when we are using fluorescence screen? So when particle strikes that fluorescence screen, so it shines, right? So after that shine, we found the traces on that sheet, and we can easily identify that there is something which strikes at this specific point, right? And from this diagram, you can also identify that from the center, the particles reflect back or just completely bounce back. And the other part of the gold foil shows you that particles just move in a straight line without any deflection. Okay. Any confusion?
No, sir.
And initially, why this model or why Rutherford announced was as the Nobel Prize for this whole experiment? Why he got the Nobel Prize for this experiment? Because the initial observation and the initial, we can say that the idea about the structure of the atom was different, right? You studied about plum pudding model, right? You know about it, plum pudding model. What was that?
Yeah,
I've heard the name.
Yes. Any idea what was that plum pudding model?
it was an idea about a plump with a bunch of
Yes.
electrons randomly
Yes. So basically,
with no
initially,
order.
yes. So if you have any sweet dish like in a bowl and you just sprinkle up like nuts on that. So that is like plum pudding model, right? That they are just randomly distributed. There is no structure. There is no specific formation, right? And some scientists also think about this structure as that it was assumed that the atom consists of a large positive sphere, right? So these are the old assumption. So they assume that atom was a large positive sphere with electron stick on it. Okay, one basic question. You all know about positive and negative charges, right?
Yeah.
And we also use that concept in our daily life. Like in the batteries and in the cells, we are using that concept, right? So
Yeah.
let's suppose if you just take one wire and connect one wire with the positive terminal and second wire with the negative terminal, so what will happen?
They will be
Wait, can you
neutral.
repeat?
Basically, question is if there is a positive terminal
All
and there
right.
is a negative terminal also, and if you just take a
Okay.
wire and you just connect the wire from the positive to the negative terminal like this, so
You got
what
a
will
circuit,
happen?
right?
Yes, even in a circuit or with a battery or a cell or just like in the main supply of your home, so what will happen? Let's suppose you are trying this experiment in the main supply of
Would
your
it
There
be
will
home.
be a
neutral,
current
sir?
flowing.
Yes.
Current.
Yes. So basically what happens, definitely first of all, the electricity of your whole house got off, right? Why? Because you just combine the positive and negative charge. So there will be a first a short circuit, right? And then there will be nothing, no charge remains over there because your connection from the electricity will be completely cut off, right? So basically, if you apply that idea with that idea of the scientists, so they think that the large positive sphere with electron is stick on it. So if electron is stick on it, we know that positive negative attract each other, right? But not like this that we directly combine them, because you study about the neutralization in chemistry also, right? Okay, so this same things happen with this one. If you just combine proton and electron, right? So what will happen? They will neutralize. So there will be no positive charge, there will be no negative charge. So finally, you will got what? A neutral thing. There will be nothing like positive, nothing like negative in the atom. Okay, so that was the problem in the old idea. Just like the condition that we discussed, if we connect the positive terminal with the negative terminal, so we know everything will be neutralized. There will be no direction of current flow from one end to the negative end. If we are using load in the circuit, so that is a different scenario, right? But in this scenario, we only discuss that we connect one end to the other end. So your charges will be neutralized, right? There will be no charge left out like positive or negative. Okay, so what was the observation taken by this experiment? And you already know about the experiment, how this experiment performed. A beam of alpha particle, we use beam of alpha particle first, right? And that beam of alpha particle just, we try to strike that beam of alpha particle on a gold foil. And what will happen? And we place fluorescence screen. to detect the particles, that where the particles are moving or in which direction they are moving, right? Clear? Any confusion?